This is Dr. Manjuna Chennapgot from Anveshana Academy, Bangalore, India. Okay, dear students, in the last class we discussed about what is unification and reductionism. With many examples, I have discussed in detail about unification and reductionism. Okay, so now I will move towards next topic. That is laws and theories. So these laws and theories are very important aspects in physics. These are the two important concepts in physics. So what is law? We'll study now. Okay, what is law? Law is a scientific law is a concise description of natural phenomena that consistently holds true under specific conditions. I repeat, a scientific law is a concise description of natural phenomena that consistently holds true under specific conditions. That is known to be a law or scientific law. And it is typically expressed in terms of mathematical equation or a simple statement. So the law can be expressed in mathematical equation and they are concise and simple statement. And this law will describe what happens. That means what something happens, right? You can take some events or observations or incidents. What observation happened, what incident happened, what event happened, that will be described by a law, but it will not explain why that event or incident observation happened. It will not explain the reason for the event which is happened, but it will tell what actually happened there. It will tell. That is a law. Okay, so now these laws are based on the repeated observations and experimental evidence. Before giving the law, what they will do? They will do repeated observations and experimentation. Then they will give the law with sufficient evidence. Okay, one thing. And whatever the law they are going to give, right, it is to be considered universally and it is valid universally. Okay, and that can be used for the different applications. The laws are universally valid and accepted for the different application. Okay, those are the laws. Okay, fine. So now quick recall, you can see here now. What is scientific law? Scientific law, it is having some key characteristics. What is the key characteristics? It is a concise and simple description about the event happening or observation happening, and that law can be expressed in terms of a mathematical equation. Okay, with the help of mathematical expression or equation we can write the law. One thing. And so what are the examples are there for these laws that you can see here, dear students? You can take Newton's law of gravitation. One thing, laws of thermodynamics, Ohm's law. These all are the laws actually. These are the examples for laws. And what it is going to describe? It is going to describe that to in concise, in simple word, in simple statement it is going to give. And whatever the phenomena happening in the nature, right, it will give in concise description. That is known to be law. How it is then? With some 2-3 live examples I will try to explain you what is actually law. So yeah, as I told, it's a simple statement or concise description of a phenomena which is happening in our day-to-day life or in nature we can take. Dear students, you can take now. Here one man is hitting the football. That ball will come, it will move in this direction. He's hitting the ball with the help of some force, you can call it as F1. Then it will come and hits the wall. Then what wall it will do? It will react with same force, that is F2. Then what happens? The ball will come and hits the wall and it will come back with same force, that too in opposite direction. That is nothing but what? Newton's third law of motion. So what is Newton's third law of motion? is simple. It's simple, right? It's a simple statement or it's a concise statement. What is that? For every action there is an equal and opposite reaction is there. In a simple statement he has given the law Newton, that we call it as a Newton's law of motion. That too, third law of motion. So that is what one example, law of motion. Okay, similarly that is what law of third law of motion. Second example you can take thermodynamics law, laws of thermodynamics or thermodynamics law. I will take first law of thermodynamics. What is first law of thermodynamics? By seeing the equation itself we can understand here now. Cyclic integration of heat supplied is equal to cyclic integration of work done. In simple terms, amount of heat supplied is equal to amount of work done. I repeat, first law of thermodynamics, what it tells, amount of heat supplied is equal to amount of work done. That statement, it's a concise and simple statement about an event. About an event is nothing but what? Getting heat, transferring heat from one part to another part. That can be expressed with the help of an equation or expression. That expression is cyclic integration of dq is equal to cyclic integration of dw. That is nothing but what? Law. This is a concise statement. Fine. One second examples you can take. You can take third example. What is third example? Electricity moving. Okay, so electrical energy is moving here now. Then with the help of Ohm's law we can calculate how much amount of current is moving. That is I, how much amount of current is moving. With the help of law we can calculate the rate of current flowing. That is nothing but what? Law. What is that law? With the help of Ohm's law. Ohm's law is what here now? Ohm's law you can take, dear students. Okay, V is equal to I into R, where I is current, R is the resistance and V is the voltage. With the help of this Ohm's law, what we can do, I can calculate the amount of current flow. Okay, that's the one thing now. If it's so, then that we can call it as a law actually. Okay, that concept, the amount of amount of current transferred can be calculated with the help of an expression or equation. This expression or equation is nothing but what? Ohm's law. This is about. Okay, now I will move towards next concept, that is theory. What is theory? You can see now, a scientific theory is a well substantiated explanation of some aspect of the natural world that can incorporate facts, laws, inferences and tested hypotheses. Okay, then you can see here now, dear students, what actually this theory does. This theory is going to explain why the phenomena occurs. Before we studied law, what it will tell, what actually happened if you observe some phenomena, if you observed some phenomena, observed some phenomena in nature. So what happened, that phenomena that will be explained by a law. Fine. Why that phenomena is happening, that is explained by a theory. Okay, the theory will give the reasons and it will give the descriptive explanation or framework for that phenomena, why it happened. Okay, so what actually does theory here now? Theory is going to explain why a phenomena occurs in nature. Okay, and that theories are also supported by large body of evidence from various sources. The scientists, what they will do before giving the theory, also they will do a lot of experimentation. With the proof, what they will do, they will give some theories. Okay, and these theories are subjected to revision. You can take or refinement, whatever the theory which are given by the scientist, right? After repeated experiments with some evidence, they will give theory. That theory can be revised or refined or modified with the evidence emerges. With some evidence we can modify or we can refine the theories, but laws cannot be modified. It is valid throughout the universe and it is accepted by universe. The laws cannot be changed or cannot be modified. They are rigid laws, but theories can be modified as per our requirement with some evidence, that is theory. Okay, and theories, what they will do, they will give some framework for understanding and predicting the phenomena. So whatever the phenomena which is happening in nature, right? So you can take as I explaining, mango is falling from a tree to the down, right? What actually happening? Falling of mango, it is what actually happening, the event, it is law. Okay, then why that mango is getting fall down, the reason is explained by theory. Okay, in simple term, what is theory actually? Theory is a description of a description which incorporates facts, laws, inferences, and tested hypothesis. This is what theory. And what are the key characteristics? It is having some characteristic. It will give detailed explanation about the event or a phenomena which is happening in nature, one thing. And that event, that explanation, whatever it will give, right, it will give complete or comprehensive explanation which will give, or it will give towards a phenomena. It will give with what? That explanation or comprehensive explanation will give based upon the evidence, based upon the repeated experiments, one thing. And whatever the theory where scientists they are going to give, right, that can be refined or modified as per the requirement with proper evidence. That's the one thing. So some examples for theories are theory of relativity, you can take theory of quantum mechanics, theory of plate tectonics, you can take. What is that? You can see now. One I will consider here now, theory of quantum mechanics. What actually it is going to do? Quantum mechanics will describe, just a minute. Okay, quantum mechanics describes the behavior of a matter and energy at the atomic and subatomic level. Quantum mechanics is a theory. It is going to explain the behavior of a matter and energy at the atomic and subatomic level. That is nothing but what? Theory. To understand better theory and law, I will take some live examples and I will try to teach you, dear students. Okay, you can see now what is law actually. I will take one example here, Newton law of cooling. I can take one theory, that is kinetic theory of gases. Okay, so now what is Newton's law will do here now? It will quantifying the heat transfer. That means what? You can take any object, or a body. If you are transferring heat to the body, right, you can take, if you are supplying you are supplying certain amount of heat Q, then how much amount of heat you have supplied, or else how much amount of heat is absorbed by the body, that how much quantity, that can be explained by a law. But it will not give the reason why the heat is getting transferred, why the heat is transferring from one end to another end. It will not give the reasons, it will not give why it is so happening, but it will give how much amount of heat is getting transferred with the help of an expression. That expression we can call it here, that expression is what? H into A into delta T. That this expression is given by whom? Newton. That law we can call it as the Newton's law of cooling. That law can be expressed in terms of expression, and it is a concise statement that we can see here now. Then to transfer the heat, what actually the convective heat transfer play a very important role. That also well explained in the law, one thing. Whereas when it comes to theory, that you can take a kinetic theory of gas, when you're transferring heat into the gas, right, then gas, or you can take any fluid, then fluid particles movement will be there. How they are moving, what velocity they are moving, what is the energy between one molecule to another molecules, that will be explained, because heat is getting transferred, right? Heat is getting transferred in convection heat transfer because of molecular motion. How because of molecular motion, right? This reason will explained by a theory. That theory we can call it a kinetic theory of gases. Fluid movement it will explain, and properties of the fluids, that can be explained with the help of a theory. That theory we can call it as a kinetic theory. Okay, in quick recall, what is kinetic theory? It provides foundation understanding of gas behavior and fluid dynamics. Why the gas is moving, what force it is moving, that will be explained by kinetic theory. Whereas Newton's law of cooling, what it tells during heat transfer, what it will do? It will simplify. It will give the how much amount of heat transfer. That means what? It will give. It is telling the heat transfer event is happening or incident is happening. or heat transfer phenomena is happening, that will tell that much only. But why the heat is getting transferred, that will not explain by a law. This is one example. So to understand better, I will take one live examples and I will try to understand you. Okay, you can take the students. So before that, what is law here now? In simple term, it is a concise universal statement, and it is a concise descriptive, and it is accepted by universe. It is valid in the universe and it cannot be changed or it cannot be modified, and that law can be expressed in terms of equations or expressions, we can say. Now, what is theory? Theory is nothing but what? It's a comprehensive explanatory of frameworks. Whatever, whenever we are going to give some theory, right, it will give some comprehensive description per event, why it is happening, one thing. And it's a integrative and evolving. The theory can be modified. Theory can be modified based upon our research with the proper evidence. That is possible in theory, but modification is not at all possible in laws. Okay, fine. To better understand of this theory and law, I will take one example, live example. In our day-to-day example, I will try to explain you. What is that? You can take here now. Newton's law of cooling is what? Law. Okay, kinetic theory of fluid, heat is getting transferred. Why? Because of molecular motion. Because of molecular motion. You are telling reason why the heat is getting transferred, that is theory. Heat is getting transferred, that is law actually. That is nothing but what? Law. That too, heat is getting transferred. The heat transfer is represented by Q actually. Okay, fine. Dear students, you can take it here now. One example application you can take. You are boiling the water. You can example boiling the water. The water is getting transferred from heat source to the heat is getting transferred from heat source to the water molecules. The water molecules, what they will do? They will absorb heat and they will keep on moving. That means what? Because of the molecular motion, heat is getting transferred. If the heat is getting transferred because of molecular motion, that type of heat transfer can called as a convective heat transfer. That convective heat transfer is represented as Q is equal to H into A into delta T. This is nothing but what? Newton's law of cooling. That means what? Heat is getting transferred in fluid because of molecular motion. That is nothing but what? Newton's law of cooling. That is HA into delta T. This Newton's law, what actually doing here now? It will tell us about how much amount of heat is getting transferred. That's it. But why the heat is getting transferred? It will not explain. To understand that, theory will come here now. Why the heat is getting transferred? Heat is getting transferred because of molecular motion, molecular energy transfer. That is explained by theory. Theory, what it will do here now? It will explain why heat is getting transferred. Theory, this how much amount of heat is transferred. That quantification is done with the help of an equation or expression or a law. That law can called as a Newton's law of cooling, dear students. That what is the equation here now? Heat, convection heat transfer. Because convection heat transfer is happening now, Newton's law, what it tells? How much amount of heat is getting transferred. What actually happening there? It will tell. Why the heat is getting transferred? That is explained by theory. Okay, fine. That Newton's equation you can see here now. One thing, and one more thing you can see here now. Assume that you are a body. When you are standing outside, right, then what happens? Your heat is going to transfer from your body to the surrounding. Assume that your body temperature is for 35 degrees Celsius and outside temperature is 25 degrees Celsius. Continuously heat is going to transfer. How much amount of heat is transferred can be calculated with the help of Newton's law of cooling equation. What is that? Q is equal to HA into delta T. Fine. How much amount of heat transfer? That is law, Newton's law of cooling. Then why the heat is getting transferred? Because of the air which is moving here, it is going to interact with the your body and it will absorb the heat. It will come out. Because of this reason, heat is getting transferred. That reason is explained by a theory. That theory we can call it as a kinematic theory of fluid. That is what theory actually, dear students. Okay, fine. Now quick recall. What is law? Law definition for law is, laws are concise description of observed phenomena. What are the characteristics? It is universally valid under specific conditions. Okay, and based on some observations. Examples: Ohm's law, Newton's law you can give. When it comes to theory, what is the definition for theory? Theories are a comprehensive explanation of phenomena. One thing, characteristics, they are well substantiated and they can be modified. and they are the predictive frameworks. Okay, examples for theories are general relativity, you can take quantum theory, you can take, dear students. Okay, now, so what are the difference between theory and laws here? Now, theory, laws will explain, it will describe what happens in nature. What are the characteristics of laws? Universally it is valid based on observations, and examples for laws are gravity, Newton's law you can take, Ohm's law you can take. When it comes to theory, it explains why the phenomenon is happening. Okay, what are the characteristics? It is well substantiated and it can be modified. What are the example for theory? General relativity and quantum theory. Okay, fine. Now, so why we need to use the laws and theories in science? Okay, there is some distinct role, there are some roles of laws and theories in science. What are those? Scope, laws will describe specific phenomena, while theory will give the detailed description about that phenomena. I repeat, laws will describe some phenomena which are happening in nature, but theory will give detailed explanation or a description about that phenomena. One thing, laws, so it will tell what actually happened. Theory will give the reason for the things which are happening in our nature with a detailed explanation. Then flexibility, you can see now, theories are adaptable, theory can be modified and it can be adaptable. Okay, but laws cannot be modified because they are more rigid, they are universally valid. Laws cannot be modified, but we can modify theory. Okay, development, theories integrate and explain multiple laws. Theory, we keep on doing research, theory can be modified or it can be integrated and that can be applied in multiple laws. Okay, so uh, thank you for your uh, uh, thank you. And one thing, dear students, here with I request you, most of the students not yet you subscribed my channel and you not given a comment and you not like my video also. With a lot of efforts I am doing such kind of videos to understand physics in detail. Here with I request you, please subscribe my channel and don't forget to subscribe my channel. Hope you will support me to do more and more video like this. Thank you.